Hello students, in this video we are going to solve some problems, and if you have not watched my previous isotopes video, I would highly recommend you to watch that video so you can really understand the problem here. First I have drawn this table because this table would make things a lot easier and it would make things a bit more organized when you try to solve problems. Okay, now just a bit of recap. Whenever we know the percentage of an isotope, so for example, if this is 20% and this is 80%, and we know the mass, for example, let's call it a 5 and let's call it 10, and we can actually find the average atomic mass by multiplying these two and then getting the total number. So these would be 20 into 5 because this is a percentage, so you have to put 20 over 100 plus 80 over 100 into 10, and whatever number you get, that's actually the average atomic mass. So that is pretty much how you solve to find the average atomic mass when the isotopes are given. So let's look into this problem. So if you look at this problem, you can see that this is not so. You can see that this is not so clear. The problem, like our percentage is given, but what's given is actually sort of a ratio, and that's something you have to really take into mind. So first, what we are going to do is we are going to point out the important things, this question. Okay, so what do we have here? So what we have here is that, let's pick the color. Yep, it's all good. So what we have that the mass of a spectrum, it's an unknown element, Z, and we know the mass. The mass is given, it's one at mass 80. So we can put this here, and one at mass 81. So let's call this first one isotope 1 and the second one isotope 2. And what else is given? Okay, let's see. The intensity of the peak at mass 80 is twice that of the peak at mass 81. Now, if you remember from my last video, that we always get this graph, and it's the percentage abundance, and here we get our mass over the charge, okay? And then we get different kind of peaks here to kind of represent how much mass we have and at what percentage. So let's draw here. So since we are given here, so we have, it's 80. This is 80. So since it's going to be the first one, 80, and it says that this one is twice of the peak at mass 81. So this one is going to be twice for 81. So if we call it 80, and this, let's say 81. So if this is X, this one, this is going to be some basic maths. This is going to be 2x, okay? So we can also put this here. So for isotope 1, this is 2x. And for this one, it's x. Now, when we use the equation, if you remember, the equation is m1 p1 plus m2 p2. Now we can use this equation straight away. And since we are given the average atomic mass, which is 80.32, we just have to find x. So let's do that. So this is going to be x over 100 into 81. This one is going for the isotope 2. And then we have 2x into 80. So this one is given 80.32. And if you solve this, and I hope you know how to solve this, we are going to get x equals to 33.32. Now, this one, what does this mean? This one is actually now representing the percentages, okay? So now we can put this value straight away here. This is going to be 3.32, and we know this one is 2 times, so this one is going to be 66.7%. Now, if you add these things together, it's going to be 100%, which makes sense because whenever we're talking about relative percentage abundance, we're actually talking about 100% and how much of it is divided into different isotopes. Now, we have already done this, determine the relative abundance of both isotopes of Z. So for isotope 1, we have found it at 66.7, and for isotope 2, we have 33.32. Now, determine the number of neutrons in the most abundant isotope of Z. So we have 2 isotopes, and which one do we have the most? We have this one, 66.7. So isotope 1 has 66.7%. So this one is my most abundant isotope. And what it asks me to find is to find the number of neutrons. Okay, how do we find out the number of neutrons? we need to know the mass, okay, the total atomic mass, and then we know that total atomic mass consists of proton plus neutron. It's not going there, but let me write it here, be easier. So we know that the total atomic mass, whenever we are talking about the total atomic mass, what we are essentially talking about is the mass of proton and neutron. Now, we know the total atomic mass for the most abundant isotope, which is going to be 80, and we know the proton, because it's given there, it's 45, and we have to find the neutron. So when you do the calculation, you find that the number of neutron is 35. Problem, which is relatively quite simpler than the other one, but at the same time, it also uses normal mathematical reasoning and logic behind. So you should at least know the basic algebra maths. So, okay, for this one, okay, what is given? Okay, we are given the total average atomic mass, which is 35.453. Okay, so we can put this here, 35.45. This is not really a good color. We can use a better color. Let's use red. So 35.453. And what else is given? Okay, we are given Cl35 and Cl37. Now, if you remember, Cl35 means that whenever we see a number after the element, it means that this is actually talking about the atomic mass. So let's say this one is isotope 1, and we call the atomic mass is given 35, and for this one is 37. Now, what is not given is actually the percentage, and we can use some mathematical reasoning. Let's say we know that the whole thing, okay, if we add whatever percentage we get and whatever percentage we get here, it's going to be 100. So if we call this x, this one should be 100 minus x. So, for example, if this is 50, this should be 50. If this is 70, this should be 30. So using that logic, we can just put an x, and using the same equation as last time, we can do it x over 100 into 35 plus this one is going to be 100 minus x, also divided by 100 because it's a percentage, into 37, and we know the total average atomic mass is given 35.453. Okay, now we can solve x. You can do this, I hope, and what we get is x is actually 77.35%. Now, okay, so what does that mean? So this one, so we have found it, and we can also erase this. So this one is going to be 77.35, and this one is going to be just minus that. So what we get is 22.65. So this actually makes sense, right? Because we have our most abundant isotope is actually closer to this mass, and that's why we get our atomic mass, average atomic mass, close to 35. I hope you understood this.